The Earth, a small blue planet floating in the vastness of space, is surrounded by an invisible yet essential blanket, the atmosphere. This blanket is composed of layers, each with its unique characteristics, working together to shield the planet from the harsh realities of the cosmos. The chapter begins with a detailed exploration of the atmosphere's composition, from the troposphere, where weather occurs, to the exosphere, the outermost layer where the atmosphere thins out into space. The atmosphere's first line of defense is its ability to filter out harmful ultraviolet, UV, radiation from the sun. As sunlight passes through the layers, particularly the ozone layer in the stratosphere, most of the dangerous UVB and UVC rays are absorbed, preventing them from reaching the Earth's surface. This protection is crucial for all life forms, as prolonged exposure to these rays can cause severe health issues like skin cancer and cataracts, as well as damage to the delicate ecosystems. The chapter also delves into the history of the atmosphere, explaining how it developed over billions of years. The emergence of oxygen, primarily through the process of photosynthesis by ancient cyanobacteria, transformed the atmosphere into a life-sustaining shield. The chapter concludes with a look at how the atmosphere continues to adapt, responding to the ever-changing conditions of the Earth and the solar system. The vastness of space is not empty but filled with debris, including meteoroids, asteroids, and comets, hurtling through the void at incredible speeds. Without the atmosphere, Earth would be bombarded by these space rocks, causing catastrophic damage. This chapter focuses on how the atmosphere acts as a protective barrier against these cosmic threats. When a meteoroid enters the Earth's atmosphere, it encounters intense friction with the air molecules, causing it to heat up and burn. This process, known as ablation, transforms the meteoroid into a bright streak of light, a meteor or shooting star. Most meteoroids disintegrate completely before they reach the ground, and those that do survive are significantly reduced in size. The chapter includes vivid descriptions of the physics behind this process, illustrating how the atmosphere's density plays a critical role in protecting the planet's surface. The chapter also examines historical impacts, such as the Tunguska event and the Chicxulub impact, which led to the extinction of the dinosaurs. While these events were devastating, the atmosphere mitigated their effects to some extent, preventing even greater destruction. The chapter concludes with a discussion on the ongoing monitoring of near-Earth objects, NEOs, and the importance of the atmosphere in providing humanity with time to prepare for potential impacts. The Earth's temperature is a delicate balance maintained by the atmosphere, which acts as a thermal blanket, trapping heat and redistributing it around the planet. This chapter delves into the greenhouse effect, a natural process where certain gases in the atmosphere, like carbon dioxide and methane, trap heat from the sun, keeping the planet warm enough to sustain life. Without the atmosphere, Earth's surface would experience extreme temperature fluctuations, from scorching heat during the day to freezing cold at night. The chapter explains how the atmosphere regulates these temperatures, ensuring that life can thrive in a relatively stable environment. It also explores the role of different atmospheric layers, such as the troposphere, which traps heat close to the surface, and the thermosphere, which absorbs high-energy solar radiation, preventing it from reaching lower layers. The chapter also addresses the impact of human activities on this delicate balance. The increase in greenhouse gases due to industrialization has intensified the greenhouse effect, leading to global warming and climate change. The chapter concludes with a discussion on the importance of protecting the atmosphere to maintain its role as a thermal shield and the steps being taken globally to mitigate climate change. The sun, while essential for life, also poses significant dangers to the planet. Solar radiation, particularly during solar flares and coronal mass ejections, CMEs, can be extremely harmful, potentially disrupting communication systems, power grids, and even life on Earth. This chapter explores how the atmosphere, in conjunction with the Earth's magnetic field, acts as a guardian against these solar threats. The chapter describes the different types of solar radiation and how the atmosphere, particularly the ionosphere and the magnetosphere, interacts with them. The ionosphere, filled with charged particles, reflects and absorbs radio waves, protecting the planet from harmful high-energy radiation. The magnetosphere, created by the Earth's magnetic field, deflects charged particles from the sun, directing them towards the poles, where they create stunning auroras instead of causing harm. The chapter also examines the historical impacts of solar storms, such as the Carrington event of 1859, and how the atmosphere helped mitigate their effects. The chapter concludes with a look at current research on solar activity and the measures being taken to protect modern technology from future solar events. As the Earth's atmosphere continues to shield us from the cosmic and solar threats that abound in space, its own integrity is increasingly compromised by human activities. This chapter delves into the complex challenges facing the atmosphere, highlighting how the actions of humanity are threatening its ability to protect life on Earth. The atmosphere, composed of a delicate balance of gases, is not impervious to change. Over the past century, industrialization, deforestation, and the burning of fossil fuels have significantly altered this balance. The chapter begins with an exploration of the greenhouse effect, explaining how the increase in carbon dioxide, methane, and other greenhouse gases has amplified the natural process, leading to global warming. The Earth's once stable thermal shield is now becoming a contributor to rising global temperatures, leading to more extreme weather patterns, melting polar ice caps, and rising sea levels. The chapter then shifts focus to the depletion of the ozone layer, a critical component of the stratosphere that absorbs and blocks the majority of the sun's harmful ultraviolet (UV) radiation. The discovery of the ozone hole in the 1980s, caused by the widespread use of chlorofluorocarbons, CFCs, in refrigeration, aerosols, and industrial processes, was a stark reminder of the fragility of our atmospheric shield. The Montreal Protocol, an international treaty signed in 1987, is discussed as a case study of global cooperation. The treaty successfully led to the phasing out of CFCs, allowing the ozone layer to slowly recover. This section underscores the importance of collective action in addressing environmental issues and the need for vigilance to prevent future harm. Air pollution, another significant threat, is explored in detail. The release of pollutants such as sulfur dioxide, nitrogen oxides, and particulate matter from vehicles, factories, and power plants is not only detrimental to human health but also contributes to acid rain, which damages ecosystems, buildings, and even the atmosphere itself. The chapter provides vivid descriptions of the smog-filled cities, where air quality has deteriorated to the point of becoming a health crisis. It also examines the impact of pollution on the atmosphere's ability to regulate the planet's climate, with particular emphasis on the warming effects of black carbon and other aerosols. The chapter also touches on the lesser-known but equally concerning issue of space debris. As humanity's ventures into space have increased, so too has the amount of debris orbiting the Earth. This space junk poses a threat to satellites, spacecraft, and even the International Space Station, ISS. While not directly affecting the atmosphere, the potential for collisions could lead to more debris entering the atmosphere, with unpredictable consequences. In the final section of the chapter, the narrative turns towards the solutions and actions being taken to protect the atmosphere. The chapter highlights international agreements, such as the Paris Agreement, which aims to limit global temperature rise by reducing greenhouse gas emissions. It also explores innovative technologies being developed to combat pollution, such as carbon capture and storage, CCS, and the shift towards renewable energy sources like solar and wind power. The chapter concludes with a reflection on the interconnectedness of life on Earth and the atmosphere that sustains it. The atmosphere, while resilient, is not invincible. It requires our protection, just as it protects us. The story ends on a hopeful note, emphasizing that while the challenges are great, so too is the potential for positive change. By understanding the importance of the atmosphere and taking collective action, humanity can ensure that this fragile frontier continues to serve as our shield against the vast and often hostile universe.